All right, so we just cooked up a formula for the derivative of a function that is itself a sum of two functions. And sort of a natural question from that is, okay, if we have the ability to compute the derivative of a sum of functions, well, simply by taking the derivative of each piece and summing them together, well then, is there a way to find the derivative of a difference of functions? Which is to say when two functions are being subtracted, which is totally cool to do, right? Because instead of x squared plus whatever square root x is, you could look at x squared minus whatever square root x is. And then the question becomes sort of how does that manifest in the derivative? Now you could imagine what you would want it to be, or hope it to be. The derivative of a sum is very simple. You just take the derivative of each piece, add them together. Maybe the derivative of a difference is just as well, where you take the derivative of each piece and subtract them together. Well, let's see what the evidence is to support or deny that. So if instead of a sum of functions, we want a difference of functions, how is that going to affect the work that we've done previously? Well, here we've got f minus g, so we're going to need f minus g on the right as well. So everywhere we had f plus g, we're just going to write f minus g. Now we've made the proper adjustment. Okay, how is that adjustment going to manifest itself in the next step? Well, looking at the f of x plus h, that is positive above and positive below, so that checks out. Looking at the f of x, that's negative above and negative below, that actually checks out. Now let's look at the g's, because we have a negative g of x plus h above, but a positive g of x plus h below. That has opposite sign. So one way to change that opposite sign would be to take the plus that's in between and replace it with a minus. So now the negative g of x plus h above is consistent with the negative g of x plus h below. And what about now the g of x, because that's the last term we have to look at? This is minus a negative, which is a positive, and here we have minus a negative, which is a positive. Okay, so the act of changing that plus sign in the middle to a minus sign accounts for the negative g of x plus h and the positive g of x. Cool. So what's that going to do from this step to the next step below? Well, remember we broke apart our subtract, or rather previously our addition expression to be like 4/7 plus 1/7. Well, here it's going to be 4/7 minus 1/7, because instead of having a plus in between, now we have a minus. So instead of having a plus in between, now we have a minus. But now you can see that doesn't actually affect what's in the brackets. It only affected the plus sign in between, which became a minus sign, so the plus sign in between becomes a minus sign. And the long story short is, the derivative of a difference is the difference of the derivatives. It sort of is exactly what you would hope, which is to say, when you have a function which is a difference of two functions, what do you need to do? You just need to take the derivative of the first and the derivative of the second and put a minus sign in between. Problem solved.